This video is for section 3-7, linear inequalities and systems. The four graphs below show linear inequalities that are related to the equation y equals x. Each graph has a shaded region called a half plane, bounded by the graph of y equals x. If that boundary line is part of the region, the line is solid. If not, the line is dashed. So this picture shows the four inequalities that can be written by changing the equation y equals x into an inequality by using one of the inequality symbols. First, we have y is greater than or equal to x. Notice it has a solid diagonal line. That's the line y equals x, where 0, 0 is on the line, 1, 1, 2, 2, and so on. And you'll notice the shading above the line. Let's think about why dots above that line are shaded. If you choose a dot in the shaded region, for example, this one here at 1, 3, what do you notice about the value of y, 3, compared to the value of x, 1? The y is greater than the x, and that's what the inequality statement is saying. There are an infinite number of points where the y-coordinate is greater than the x-coordinate, and they exist above that diagonal boundary line. The next picture shows y is greater than x. Notice it's the same as the first picture, but the boundary line is dashed because any dot on that line does not satisfy that inequality. For example, this dot here is 1, 1, and the y value 1 is not greater than the x value of 1. The next inequality has a less than or equal than symbol. Notice the solid line, and this time the shading is below that boundary line because of the is less than arrow. The final picture is y is less than x. A dashed line because there's no or equal to symbol, and the shading is below the boundary line because of the less than arrow. Let's try an example. Graph the inequality 2x minus y is less than, this should say 3 here. Based on the pictures we just looked at, we expect this to have a boundary line and shading that's above or below that line. Let's locate the boundary line by changing this equation into slope-intercept form. So over here on the left side, I'm going to rewrite the equation and get the letter y alone. First, subtract 2x. That makes negative y is less than negative 2x plus 3. Then divide everything by negative 1. When you divide by a negative, the arrow switches direction. Negative 2x divided by a negative is positive 2x. 3 divided by a negative is negative 3. I've changed the open sentence into slope-intercept form because that will make it faster for me to draw the boundary line and to know where the shading is. The y-intercept is negative 3. So let's locate a dot at negative 3. The slope is 2, or 2 over 1. So from the dot, rise 2 and run 1. Rise 2, run 1. Rise 2, run 1. Before we draw that in, let's determine if that's a solid or dashed boundary line. Look at the symbol in the open sentence. Solid or dashed? It's dashed. Next, determine where to shade the half plane. Again, look at the inequality symbol. We want to shade dots that are greater than our boundary line. That would be shading above. So everything above that dashed line, shaded in. This picture is the graph of this inequality. Next example, let's graph a system of inequalities. Before we do this, let's think about what we expect it to look like. This will make a line with a dashed line and shading. This one here will also make a line with a solid boundary and shading. Let's find those lines. I'm going to take the first inequality statement and change it into slope-intercept form. Subtract 2x and divide by -1. Remember to reverse the arrow when you divide by negative. This is the same inequality we just did. So it crosses the y-axis at -3 and has a slope of 2. Let's find several dots to improve accuracy. Remember that the shading is above that line. Now our next inequality, let's change its form as well. First, the distributive property. 3 times 1 is 3, 3 times -y is -3y. Next, add 3y. Next, subtract x. And divide by 3. This one has a y-intercept at 1 and a slope of -1/3. Down 1 unit, right 3 units. Down 1, right 3. Down 1, right 3. Is this boundary solid or dashed? It's solid because of the or equal to on the symbol. So let's draw it in. And then think about where the shading is. This is a is less than symbol, so the shading is below the solid line. What region of space on this grid is above the dashed line and below the solid line? Above the dashed line, but stay below the solid line. That's this region of space. Every dot that we're shading over is a solution to this system of inequalities. Notice the technique used to get that graph. Graph the first boundary line, thinking about if it's solid or dashed. Graph the second boundary line, thinking about if it is solid or dashed. Then, figure out where the shading goes. Let's summarize the lesson. We reviewed how to graph inequalities on a grid by drawing a boundary line and shading a half plane. Then we combined inequalities to make a system, which would have 2 boundary lines and a shaded region.